we build robots that are used to inspect jet engine turbines for cracks, non-destructive inspection. So after an engine's been stressed a lot, they'll swap it out and tear down, each rim, each blade, and put it on our robots. And the robot takes these sensors over every surface of every blade and every bolt hole and every part of the turbines, looking for potential cracks. The main thing is some graphs. And we had used open source in the past, and it wasn't really supported. So we thought, no, it'd be good to go with the commercial software. And the old stuff, there was just no documentation, and it was open source and quit being supported. And I think, the fact that it's supported, because our products tend to be out there for many, many years. So we need to make stuff that's going to continue, and we can move it forward with new, versions of the compiler and so forth. So maintainability was the main reason we went to commercial, and I feel like Syncfusion's good at that. They support all the new stuff that comes out, and it seems like what little I've seen, that there's backward compatibility. We can still run old versions if we need to. And basically, we're doing signal analysis, so we inject a signal into the metal and then look at the response signal. In the early days, we had oscilloscopes hooked up, and now we've kind of replaced that with graphs, real-time graphs of the signal. This kind of provides a visual for debugging and kind of a comfort level that, it looks normal, and if not, they can determine some things from the signal. The main one I've been working on is WPF. There's another one that is actually using Windows Form. And then we have a reporting and post-analysis that is in Blazor. There's this huge application that does most of the analysis and talks to the robot. And when it talks out to the sensors, there's another application that talks through, that kind of analyzes the messages going across and lets you do some extra debugging of what's going on in the embedded sensor out on the tip. But the control of the tip of the robot, use the radial slider for that. As you move the dial, it's moving the tip, and that's used for calibration of that. And then there's all these different tips. So, the range of values shown and the orientation. And so, you had those controls, but it's like we were really pushing the limits on how they work. Eventually, I think they did end up, making some changes to the underlying control, and so it was good. So the support's been real good.